Good evening, everyone. Welcome to my YouTube channel. My name is Imani Shimwe 34. Today we are going to talk about statistical machine learning model building for the assignment that I have done in machine learning. So first, I have uploaded the dataset and then print out the summary of the head of dataset, which contain x and y, where x was an independent variable, y as dependent variable. And after, I make sample size of dataset, where I found my dataset contain 225 observations and 2 features of variables. And after, I go to the scatter plot of that variables to check the linearity. So after checking that variable, I found that there is no linear relationship between x and y. So after that, I go to the types of task. What am I going to do? So I check and I found that the task is regression because my dependent variable was continuous. And after that, I go to the second part by finding the function, where my function was defined as f, such that I will take an input in dimension rd and the output will be real number, as the output must be continuous, so must belong in a real number. After that, I check the loss function, where that loss function is the scaling the residue ensures that large errors are penalized for more heavy data response. Yeah, and after I go to the theoretical risk, where it is the measure of expected loss over the true data distribution. So, and after that, I go to the Bayes learning machine, where the Bayes machine is an optimal function that minimizes the theoretical risk. So it is an expectation of y given x. And after that, I go to the empirical risk, where the empirical risk is the function that will quantify the average loss over the training data. So I will take 1 over n summation sum of squares of y I minus f of x or I. And after that, I go to the second part, which is contain the estimation and model complexity. So I estimate the parameters of my model. So where I found that my design matrix will be looks like that, and the matrix form can be written like that. And even after, I have to minimize the empirical risk. So and then integrate my empirical risk with respect to beta. So I found that the beta will be x at x inverse x at transpose times y. So and after I comment on the properties of my function, which is linearity dependent on coefficient. So after that, I go to the cross validation, where I'm going to select the optimal polynomial that can fit my dataset. So after making the cross validation, I found that my model will have 8 will be of the degree 8. So 8 is the highest degree of my polynomial. So after that, I go to the to sketch the errors for the cross validation and empirical risk. So as you see, as an expected cross validation error must be higher than empirical risk error, as you see on the graph. So after that, I go to the model comparison, where I have to compare complexity, complex model, optimal, and the simplest model. The blue one is simple model, and the optimal model that contain the polynomial of degree 8 is one in the green. So after that, I go to the error test. Error test, I use the box plot. As you see, by using the box plot, the optimal model has smaller variance, which make it best than other models. And for the ANOVA test, I test the variation on that models, where I found that the higher significance effect of the model on the test error was founded to the simple to the optimal model. So again, I go to the confidence and prediction bound, where, as you see, my prediction bound will be covered by that red one, and the confidence of my estimate will be on the blue one. So after that, I go to the mathematical expression of confidence interval, confidence bound, and the prediction bound. So the confidence bound can be found as yi plus or minus t of alpha over 2n minus b mean square of root of x t x transpose x inverse xi. And even for the prediction interval is that one. So again, I go to the second exercise, which was the library contain KNLab, where we have to find the spam dataset and after sketch the distribution. So the distribution found that non-spam was higher than the spam, the proportion. And after that, we check the comparative LOC curve, where about the four models LDA, QDA, and naive, we found that FRD is the best for fitting my data set. And after that, we check the errors of that four models, and also as you see, the average error of FRD is smaller than others, and on the scatter plot is that one. Thank you.